Hi, I'm Loi Hong. I'm gonna to talk about the analysis circuit by using Thevenin Theorem. So first, we have to design a simple RLC AC source electric circuit. And this is a circuit we design with a inductor, a capacitor, and two resistors. And the VAC source have a 15 volts with a 45-degree phase angle. So what we have to do is determine the voltage, current, active power, reactive power, and the complex power for each component. So these are the steps using to calculate them by using Thevenin theorems. So first, we have to redraw the circuit with open circuited at the components being calculated. Second, we have to find the equivalent reactance of the circuit, which is the ZTH. Third, we have to find the VTH for the circuit. Fourth, we have to find the current flow through the component. And the final step is to multiply the current flow and the reactance to get its voltage drop. To determine the power, there are only two steps, which is simply multiply the VTH and current flow through the component to get the complex power. And the P and Q, which are the active power and reactive power, can be rated from the complex power as. Let's solve the questions. So we know that the inductance and the capacitance given are 2 Henry and 10 microfarad respectively. So for the calculations, we have to convert the inductance and the capacitance to reactance by using the formula XL equals to J omega L to find the reactance of inductor, and XC equals to 1 over J omega C to find the reactance for capacitor. And omega is equals to 2 pi F, where the frequency is equal to 60 Hz. So we redraw the circuit by replacing the value of inductance and capacitance with the reactance. So we look at the inductor first. We redraw the circuit by open circuit at the component. This is the first step. After this, the second step is to find the equivalent reactance, which is the ZTH, viewed from this point. So we series the R2 and the capacitance and be parallel to the R1 resistor, so we can get the equivalent reactance. And the third step is to find the VTH for the circuit viewed from this point. So in order to find the VTH, we first to find the current flow through the loop. In this loop. So by creeping a loop here, we can get I1. And the I1 times 8 ohms is the voltage drop at the resistor R1. And we make one more loop here, so we can get the negative Vs plus VR1 plus VTH equals to 0. So we get VTH equals to Vs source minus voltage drop at resistor 1. We can get the VTH. So we minus it, we get the VTH. And we have to draw one more time of the VTH circuit in this form. So you can see from here, we can identify the voltage drop at the inductor and the current flow to the inductor by using this circuit. So the current flow through the inductor is equals to VTH over the total impedance plus inductance. So we get this current. In order to find the voltage drop at the inductor, we just simply multiply the current flow to the inductance and the reactance, so we can get the voltage drop. To determine the complex power, we just simply multiply the voltage and the current flow through the component to get the complex power. So this is the voltage drop at the inductor, and this is the current flow through the inductor. So we simply multiply it so we can get the complex power. And since this is in J, which is the imaginary form, so we know that the active power is equal to 0 watt and the reactive power is 0.298 in positive form. So it can be proved this is the inductive circuit. Next, we identify the voltage drop, current, and the complex power for R2. So we redraw the circuit by open circuit at the component R2, and we find the equivalent reactance of the circuit from this part. So we can know that the inductance parallel to the resistor 1 R1 and series with the capacitance, we can get the equivalent reactance. So next, we want to find the VTH. So how to find it? It's just the same way as how we going to find the inductor in the previous slide. But this time, we will look at the upper side to find the current flow through R1. So we can know the I flow through resistor 1 is equal to the Vs over the total reactance. So the total reactance is 8 ohms plus the reactance of inductor. We get the current flow through the R1. And we make one more loop here, we can know that negative Vs plus voltage drop at R1 plus VTH plus Vc, the voltage drop at the capacitor, equals to 0. And since we have known here is open circuited, so the voltage drop at capacitor is equal to 0. So we just simply ignore the voltage drop Vc. VTH equals to V source minus VR1. So we just substitute the value and we can get the VTH. After we get the VTH, so we redraw the circuit by replacing VTH, ZTH, and the load. So we want to find the current flow through the component R2. Simply multiply it by using Ohm's law, which is the VTH over the ZTH plus R2. So we get the voltage drop at R2 is equal to 0.2260 with a phase angle of 133 degrees. For the complex power, we just simply multiply the voltage drop and the current flow through it. So we can get the complex power. And since this is the resistor, so we only have the active power. And we have 0 reactive power. Actually, we are going to use the same way as previous to calculate the voltage drop and the current flow through the capacitor. L parallel to R1 and the result is series with the R2. So we get the equivalent reactance. We actually know that the current flow through the capacitor is same with the current flow through the resistor too. In order to find the voltage drop at the capacitor, we just simply multiply the current flow through it with the reactance. So we get the Vc, voltage drop at capacitor, which is 14.99 with a phase angle of 43 degrees. To find its complex power, we just simply multiply the voltage drop at the capacitor with the current fluid conjugate. Conjugate is actually means the opposite sides of the phase angle flow through the components, so we can get the complex power. And since this is the capacitor, so we have zero active power but the negative reactive power. So we redraw the circuit by open circuit at the components we are going to identify. So as you can see, here is already opened. The voltage source cannot supply anything to each of the components, so they are actually just in parallel form. Second step is to find the equivalent reactance. So when here is opened, R2 series with capacitors is parallel to the inductor. For VTH, as we know, they are in parallel, so the VTH is equal to Vs, which is the source voltage. After that, we redraw the circuit by replacing VTH and ZTH. We find the IR1, which is the current flow to the resistor 1, by using Ohm's law. This drop at R1 is actually the current flow through the components times its resistance. For the complex power, same as previous, we just simply multiply the voltage drop at the components and the conjugate of the current flow to the components. As this is the resistor, so there is no reactive power stored in the components. The real power is the only power which can be used, and the reactive power cannot be used. So the less the reactive power is, the better efficiency of the circuit is.